Number 19, the density of the gas in grams per liter is, so we don't know how many moles of each of these methane, ethane, and butane that we have in the containers, but based on the fact that they all have the same temperature and pressure's all the same except for ethane, right? So remember, pressure and volume have inverse relationships. So higher volume means lower pressure, vice versa, lower volume means higher pressure. So if you look at how this ethane has the pressure of double the other ones, well, that just means the volume should be 1/2 of the other volume. So I'm just going to call these guys V, and then the ethane has to be half of that V because it's probably higher pressure due to the smaller container. So if you think about grams per liter, well, you have to understand that for ethanes, this liter is going to be half compared to the other two, so therefore your density is more likely to be doubled. Now let's take a look at the grams part. Once again, we don't really know how many moles of each of these gases that we have, but I'm just going to go ahead and assume that we have like 1 mole of each of all these, which means I can easily assume that it's going to be 16 grams for the methane and 30 grams for the ethane and 58 grams for the butane. Now, if you think about butane and ethane, that's probably the closest one here. So methane is definitely not going to be it because the gram is too small. So the numerator is going to be too small. So methane should be out. Now the question is, butane is going to be 58 grams over, let's just say V. And ethane is going to be, once again, 30 grams over, well, half of a V. So if you do the math here, well, that's going to be 60, whereas this is going to be 58. So if you compare the two, well, it's clear that ethane is the winner, which is why answer choice B is correct, greatest in container B.